Today we're looking at the properties of logarithms, very popular topic on the Regents exams. They're there every year. So we're going to take our time going through these and get lots of practice with the properties. There's a lot more problems in the book that we'll do when you come in tomorrow. And I certainly can make lots of these up as well. So let me know if you need more. First, some basic properties. If we look at these two exponential form, b to the 0 equals 1, and we change that to log form, the exponent equals log base b of 1, then what we're seeing here is that no matter what the base is, if I have log of 1, so log base 5 of 1, log base 3 of 1, log base 10 of 1, no matter what the base is, if you have the log of 1, it equals 0. Okay? This second one down, we've seen before. Of course you know that b to the first power equals b. Let's write that in logarithm form. 1 equals log base b of b. So this one says that if our base matches our number, that logarithm will always equal 1. So log base 5 of 5, log base 11 of 11, log base 21 of 21. Remember, you're answering, what's the exponent that we put on these bases? What's the exponent on 5? That gives you 5. What's the exponent on 11? That gives you 11. And what's the exponent on 21? That gives you 21. So those are some basic rules. What we really want to look at today, though, are these three other properties. The first one is known as the product rule. If I am taking the log of a product, so there's my product right there, then I expand it to equal the log of the first item plus the log of the second item. So log of x times y equals log of x plus log of y. And the base remains the same throughout. The base does not change. Quick example of this one, just to play with it a little bit. The log of 2 times 3 would equal the log of 2 plus the log of 3. You could confirm that on your calculator. You could certainly do log of 6, hit enter. Hit enter, see what you get, and then try the log of 2 plus the log of 3. Make sure you're closing your parentheses, and those two items should be equal because 2 times 3 is 6. The second property is referred to as the quotient rules. Quotient means dividing. If I'm dividing x by y, the log of x divided by y is the log of x minus the log of y. And again, just like the bases are the same throughout. Notice I didn't even put bases in this example. So a quick example of this. Let's do a numerical one so you can confirm it on your calculator. The log of 3 divided by 7. So the log of 3/7 should equal, does equal, the log of 3 minus, let's make sure that looks like a minus, the log of 7. It's pushed in there. Again, confirm this on your calculator. Let's just say my base is 10 throughout, so certainly you can use the log button on your calculator. Log of 3/7, hit enter, and then do the log of 3 minus the log of 7, and hit enter, and you should have the same results. The third rule is called the power rule. And I have a fourth rule that I sort of put with the power rule. I'll show you that in a moment. The power rule is everybody's favorite. It says if you have an exponent on your number, so log base b of x to the n, then that little exponent comes right out front and multiplies. So you can see here, n times the log of x. Quick example for that one. Log of 3 squared. Swing that 2 out front, should equal 2 times the log of 3. So let's try that one on your calculator, just to confirm. Log of 3 squared. Hit enter, and then try 2 log 3. All right, and we have matching values. So let's add on to that power rule. And you could call it a root rule if you'd like, but actually roots are powers, so it actually ties in. If I have log base b of an nth root of x, then we want to remember from chapter 7 that that's actually the same as x to the 1 over n power, if this is an index of n. And then that is just an exponent that's going to come out front. 1 over n log base b of x. So even if you have a root, the root is an exponent, and it still comes out front and multiplies. Okay? So watch out for those. Let's go and look at some of the examples. They've shown us the expansion again. Log of x times y is log of x plus log of y. So here's our first example. Log of 5 times a will equal log of 5. Since it's a product, we now add log of a. And you're done. How about the product of 3 terms? 7, m, and n. Well, log, and I have a base b, log base b of 7 plus log base b of m plus log base b of n. And we're good. So we can have as many terms as we want multiplying together. We will just add them all up if we're multiplying. All right, the quotient rule. A little reminder, if I'm dividing x by y, I subtract the separate logarithms. So this first example, log of x divided by log of 100 would be log of x minus log of 100. Now log of 100 is interesting. A couple things you'll learn as we go along the way here. If we're not indicating a base, then the base is automatically 10. So just to expand a little bit on this, log of x is log of x. That one's done. But log of 100 with a base 10 is equal to 2. Because remember, it's the exponent that goes on 10 that gives us 100. So let's try the next example. This is your answer there. Next example, log base 3 of 27 divided by 3. So because we're dividing, we will subtract. This one gives us a base of 3. So you're not done if you can actually evaluate these. Log base 3 of 27 is the exponent that goes on 3. That gives us 27. That's 3. Minus log base 3 of 3 is the exponent on 3 that gives us 3, which is 1. So this example keeps going. 3 minus 1 equals 2. And down below that, we have a couple of power rule examples. Log base b of x to the 5th. Remember that exponent just swings out front and multiplies. So I'll swing the 5 out front and write log base b of x. Done. Second example. Oh, there's a root. So the big question is, what is the index of this root? Automatically a square root. So log base 10 square root of a. That would be the same as log of a to the 1/2 power. And now we can swing that 1/2 out front. 1/2 log a. Okay? So we have lots more examples, but before we go on, let's see if you can fill in the blanks without looking up. So if I have a log of x plus a log of y, what is that the same as? If you said log of xy, you were right. And it looks like our base is given as b. How about log of x minus the log of y? If you said log of x divided by y, you are correct. And how about an n out front multiplying the log? If you said log base b of x to the nth power, you were correct. So those are the properties in reverse order. Practice them again, going the other way. You want to be able to go back and forth. Pause it and try it. I'll fill them in. Okay, did you get them right? It's a good thing to have on your formula pages and an excellent thing to memorize. You need to be able to go both ways. The previous chart went the other way compared to that one. All right, now we've got a nice full page of all sorts of examples. So let's start right from the beginning. And actually, I'm lying. I am not going to start with number 1. I am going to start with number 2 and number 3. And we'll come back to number 1. So number 2 and number 3, I have a division question and a product question. So number 2, log base 3 of 5. And with division, we subtract log base 3 of x. And that is done. It's done because I don't have, if you're thinking about numerically, there is no exponent on 3 that gives me 5, so I can finish this question right here. Number 3 is a product, so we're going to expand it. Log base 3 of 27 plus log base 3 of a. And then check out, can you do anything to simplify log base 3 of 27? this part here. And the answer is yes, you can. Log base 3 of 27 equals 3. Whoopsies, didn't mean to do that. Go back. It's equal to 3. And log of A, base 3 is just log of A, base 3. So there's your answer there. Okay, back to number 1. And the reason I skipped it is because it really has several properties all packed into one little question. So this one's going to take a little longer. First, we have a division. So I'm going to take the log of the numerator minus the log of the denominator. But I have more here. I have an exponent and a product. Let me use this little highlighter. I have that exponent, which needs to come out front. So only out in front of this log, 2 log of A times B. And one more step, I have the log of a product. I don't know why that's happening. There we go, log of a product. So I need to split that up. So I need 2 times both of them. Log of A plus log of B. And there's that final answer. So there were all 3 properties in one question. And I didn't want to jump right into that. Okay. Next set of problems say write as a single logarithm and evaluate. So we're going backwards now because I have log minus log and log plus log and log minus log. So they want us to put these back together in a single logarithm and then evaluate them, get an answer for them. So let's see what we have. Subtraction means that 32 and 8 are divided. 32 divided by 8 is 4. And the log base 2 of 4 is, the exponent is 2. Number 5, we have addition. We also have a number out front and a number out front. So we have to combine a couple of rules here very carefully. I'm going to put the half back on the 25. And I'm going to put the 1/3 back on the 27 as exponents. And you can help me figure that out. 25 to the 1/2. 27 to the 1/3. So remember, a 1/2 power means a square root. Log base 2 of the square root of 25 plus log base 2 of the cubed root of 27. That's 3. Now that we took care of the exponent parts, let's take care of the adding part. Log base 2, if I'm adding 2 logs, it means I was multiplying 5 times 3. So this simplifies to log base 2 of 15, which we cannot do anything with. Log base 2 of 15. Square root, 1/3. Okay, so we'll leave it at that. And the last one shows 2 logarithms subtracted, nothing out front, nothing out front. So let's rewrite log base 5. Subtraction means we divided 125 and 5. And log base 5, 125 divided by 5 is 5. And log base 5 of 5 is 1. Remember that matching question. If the base and the number match, of course, the exponent is 1. Okay. Number 7. So let's take care and see what makes sense here. It says expand and find the value of each expression. So I could do a couple of different things here. I think the first thing I would do is divide 5 and 30 and get 1 and 6. So that this is 2 log base 6 of 1/6. Since 5 went into 30 nicely. And I see a base of 6, so I really want it to look like something that has to do with 6 and not a 5 and a 30. So I'm going to take the exponent 2 and put that back on, 1/6, which is now log base 6 of 1/36. And now remember, I need the exponent that goes on 6. That gives me 1/36. So that is -2. Remember, you want to think of these in then form to help you evaluate. Number 8. So number 8, square root of 81 is a nice value. We could do this 2 different ways. We could take the square root of 81 and say it's 9. And log of 9 base 3 is 2. 2 is the exponent. Or, if you thought of this as saying, this is 1/2 log base 3 of 81, then it is the same as 1/2 of this expression evaluated. So what exponent goes on 3 that gives you 81? And that's a 4. So 1/2 times 4 is 2. So either way you do this way or this way, of course, either way you get the same answer. Number 9. This is a perfect example of when expanding really helps. So let's say you have no calculator. You do not know how to multiply by long way either. You're not going to do 81 times 27 in your head or with a calculator. So we're going to expand this and say this is 1/3 log base 3 of 81 plus log base 3 of 27. Notice the parentheses around everything because the 1/3 is in front of the entire logarithm. So we need the entire logarithm in parentheses. So this is 1/3 times, and now we just want to evaluate log base 3 of 81. The exponent is 4, and log base 3 of 27, and that exponent would be 3. So 1/3 of 4 plus 3 is 1/3 of 7. That's multiplying, and you get 7/3. So this, using logarithms, this example really shows that you don't need to multiply these and get some big scary number. That would be pretty tough to do in our heads, but we can split them up and figure out the question in a much simpler fashion. And the logarithms help us. All right. These are some of the favorites of a Regents exam. Given log 2 of x is a, and log 2, base 2 of y is b. write each of these in terms of A and B. We're going to let that be our last step. We'll substitute in when we're ready. We'll put an A anywhere we have log base 2 of x, and we'll substitute in just B anywhere we have log base 2 of y. So first, let's expand this. It's product, so log base 2 of x plus log base 2 of y. Now substitute in. I can substitute in A for log of x, and I can substitute in B for log of y. Done. Number 10, log base 2, it's a product, so add. Okay. Log base 2 of 4 is 2. Log base 2 of x is A from the directions. Number 11. This is xy to the 1/2 power. So the 1/2 comes out front. And we want to expand our logarithms. Log base 2 of x plus log base 2 of y. Using those properties. 1/2. Log of x gets replaced by A. Log of y, the whole thing, gets replaced by B. And there you go. And let's leave this one for class, number 12. And whoops. Didn't mean to do that. There we go. And let's finish up down here at the bottom. This one says solve each equation for the variable. So notice you have equal signs, you have equations. So these equations involve properties in that one of the sides needs you to put those terms together. So let's go ahead and do that. I'm going to follow a property and take the 5 out front. 5 log base 2 of 2 plus, and I'm going to take that 3 exponent out front, 3 log base 2 of 2. So the property I used to help me simplify this was that power rule. So I see now that 5 times log base 2 of 2 is 5 times 1. And I've got that twice. And over here, it just equals log base 2 of x. So over here, I have 5 plus 3, that's 8. 8 equals log base 2 of x. Remember, they wanted me to solve for x. So really, my only option here is to go to Venn form. So the base is 2. The exponent is 8, and those should equal x. And 2 to the 8th power, let's see, I believe is 256. 2 to the 5th is 32. 2 to the 6th is 64. Oh yeah, good job. Good job. Alrighty, that one's done. So we solved that equation. Number 14. Let's see, adding these logs, I will then take their parts, x, and multiply by x, because the logs are added. So I have log base 5 of x squared equals log base 5 of 81. Well, that's good, because that means whatever that x squared is, it's the same as 81. Perfect. So, what's my answer? You might say, because you're very well trained, that I should square root both sides and I should put a plus minus. So officially, to solve this, yes. But you will learn when we revisit the graphs of logarithms that I can do the log of 9, but I cannot do the log of negative 9. That is not in the domain of a logarithm. So actually this x squared equals 81 just gives us 9. All right, that's it. We'll be doing a lot more questions tomorrow. Properties are very, very important, very useful. I did go slow, so it's a half hour long, but you are done. Nice job. See you tomorrow.